I prepared a presentation today just on the background of renewable technologies, what we've learned in working with renewable technologies and integrating them into various different sectors, how we've done it, what has led to the decision to integrate them and the paybacks and the incentives that's gone in line with them. A bit of background on our company. Alternative Heat was established in 2002. We've over 600 biomass boilers installed to date, which equates to somewhere over 28 megawatt of installed heating capacity. 5 megawatt of this or somewhere around it being installed in Ireland, with an estimated carbon saving of 12,000 tonne a year. Example customers, we work with a wide range of different customers north, south of the border and across Scotland and the UK, from Belfast Trust, Macclesfield Council, Enniskillen Hotel, New Forge Lodge, Tory Bush Cottages, Leicestershire Police Station, number ones in the south for Dunleary Library, Wexford Horticulture Site, Galway Irish Language School, and in Scotland we've done a wide range of work for the Highland Council for a range of schools and leisure centre buildings, Glenrothes Institute of Sport, and Fife Council, the Arbor Leisure Centre, and down through England as well, through Millbrook Clare Youth School in Southampton, Brookfield Leisure Centre in Liverpool, and Turton Edgeworth School. Just to name a few of the example scenarios where systems have gone into, and I'll get into deeper detail as we go through as to why and where these applications became viable. Renewable products we offer. Alternative heat, as in the name, means any form of alternative renewable energy. We are well aware that there is more than biomass available on the ground, and we specialise in all renewable energy technologies. There is not one solution fits all, there never is, and the idea behind resourcing and working with all the technologies is that we have an open mind approach to each application, and we can look at it independently and put forward a solution which we believe best suits the needs of the client. So we work with biomass boilers, we design and deliver fully containerised plug-and-play solutions, solar panels, ground source heat pumps, air source heat pumps, and underfloor heating. And I think it's an important point in the renewable industry to establish an open-minded that certainly the one mould fits all is an issue that has arose in the renewable sector before, where certain products and certain systems have been pushed into applications that they're not best suited for, whether it be a lack of knowledge in the industry or lack of training on the products that has led it through. So it's important to keep an open mind and research the products before pushing forward what may be the wrong solution. In the north of Ireland, as Peter touched on earlier, we have the benefit of the Renewable Heat Incentive, and obviously what is driving that has been spoken about in depth today, so I'll skip over it fairly quick. The current heat demand in Northern Ireland is about 17.4 terawatt hours, currently about 1.7% of it from renewable technologies, with a 10% target for 2020. So there's quite a bit of work to do. It's going to take significant government intervention to reduce the dependency on fossil fuel and also help tackle fuel poverty, which is a growing problem in Northern Ireland. The tariffs I'll skip over briefly, which are eligible for renewable technologies within Northern Ireland, but the next slide maybe better helps explain just what those tariffs mean. And every industry and every application is different as to how hard the boiler will need to work or what energy will be produced from the renewable heating system. And this graph is put together just to give an indication of, or this table is put together to give an indication of what financially that could mean based on a 99 kilowatt boiler operating for 2,000 full load hours in a year. Between RHI income and fuel savings could generate between 15 to 20 grand a year, depending on where the application is, whether it's offsetting gas or oil. As that operating hours increase to typical maybe nursing home applications or hospital applications where 3,000-4,000 annual full load hours per year would be typical, these incentives rise significantly. So it's not hard to understand why and where the renewable products, the biomass boilers, fit in and why they make sense and how they should be pushed forward to help drive the renewable market. There's a massive rate of return on the investment, and with the RHI there's a guarantee of a 20-year income, so it's a safe bet. And again, as I say, as you run right up through with the different tariff levels, even though we have a lower tariff level on the larger scale biomass at 1.5 pence, still any 900 kilowatt boiler I'll typically be doing 3,000 to 4,000 hours a year, so significant major return on investment with 83 to 100 grand, 110 grand a year return. To date, we've submitted over 65 RHI applications which have been successfully approved. We've studied the legislation and the guidelines in depth, and we designed the heating systems in line with Ofgem guidelines, which is an important factor. The last graph is very lucrative. It works very well if you are obtaining the RHI and your scheme is benefiting not only from your fuel savings but also from your renewable heat incentive. So what we spent a lot of time is researching what these guys are looking for and streamlining the solutions to be sure they're in context with that. There's a range of different tick box exercises which is important throughout the design. As far as heat meters, they will pay based on energy generated and delivered at source or at site. So it's important to have the design compliant with the heat meters fitted in the right locations and in line with our legislation. Submitting the correct information first time speeds up the process, gets it online and leaves it much easier. Different technologies and applications. Today's primary focus is obviously on biomass boilers. Throughout Ireland and the UK, the uptake on renewables is primarily led by biomass boilers, and it's easy to see why. The application for a biomass boiler is very similar to an oil or gas. They'll work on a high temperature or low temperature system. They'll integrate into a new build or a retrofit system, which leaves a broad net for this solution. When you stop down to the leg of ground or air source heat pumps, just to touch on them, they're suitable mainly for new build. They're looking low energy, low temperature loads. So for new build, high insulated, underfloor heating, they do pose a very substantial solution, but obviously this net is much smaller than above. And likewise to touch on solar thermal, again retrofit or new build, but on a different scale of output. About biomass boilers, briefly, they're fully automated systems. They're highly sophisticated technology. Can run on either wood chip or wood pellet, and that's a strong point that I would like to touch on. A lot of today's talks have been based on wood chip. Wood chip is not the only source. Wood pellet is also a very viable source for biomass, and it's important to make the right call for your system at the design stage as to whether it should be operating on wood pellet or wood chip. Simply because certainly what comes with wood chip is a uncontrolled fuel source. The moisture content will vary depending per load, per supplier, per day. The quality of that fuel is not controlled, and therefore it's important that the end user must have a manner or a means of controlling that, either via paying per kilowatt hour in an ESCO type application, which is very viable, but again you need to be off a scale to make an ESCO work, or on a smaller scale biomass, the domestic sector, or a lot of the small scale commercial, wood pellet does pose a very viable and a solution that should not be brushed over. The capital outlay of the biomass plant is much cheaper because the augers, the transfer system, the fuel will fall under gravity and can be collected, whereas when you run on wood chip there's an element of control that needs to agitate it. Your delivery system isn't blown the same way as oil or wood pellets, and again on a project specific basis this is something that should be studied. In my mind there is systems that are suitable certainly only for wood pellet based on the full load operating hours, the size of the plant, the location, a number of different factors which I'll not dwell on. Biomass widely used throughout Europe for over the last 20 years and longer, and increasing in popularity in Ireland and the UK. They're much more expensive than fossil fuel boilers, as been touched on a number of times today, but again, the rate of return, the return on investment is very, very good, especially in the UK or in the north where the Renewable Heat Incentive is helping. Cost-effective applications boil down to quite a range, obviously. Hotels, especially with swimming pools, nursing homes, leisure centres, hospitals, industrial applications, large heat users and steam users, and housing. And I put district heat schemes here specifically because for housing plants, the district heat scheme lends itself much better to the ESCO type scenario. It is a broader outlook as far as whether it'll be suitable for pellet or chip. If you're on a one-off house scenario, house per house, for me it's a pellet system, which certainly works today, and we've shown throughout Europe that the base price of pellet has been stable, so should work in the near future. But if we open and develop these schemes into larger district heat schemes, we have more control again, where we can align ourselves with wood chip suppliers. We can start to self-sustain with willow and forestry in our local economy, and the operation and maintenance and rate of return should be much better. Agricultural sector is a wide range, from poultry houses, mushroom growers, pig farmers, the list is endless. Biomass boilers, the RHI that we benefit off in the north of Ireland and it's running throughout the UK is very, very good incentive. It makes a lot of sense, and certainly we're lucky to have it, and I would be driving and hopeful that a similar scheme will develop and come forward in the south. One thing that is important with it is an investment with a 20-year return if your product and your technology can operate for 20 years. So it's important to dig into your investment, to dig into your supplier, to be sure that the product or the technology that you're looking at is established, has shown and can deliver heat and operate and run for the 20-year period. Otherwise, what it does pose is a false economy. And we've seen that before in the north of Ireland many times through previous grant processes that come prior to the RHI, where you got £3,000–4,000 for putting in a biomass boiler. You bought the cheapest biomass boiler on the market, and it was looked at as a no or low risk type approach, which was crazy. What we believe the RHI brings to it is more stability. It makes more sense, a brilliant rate of return on investment, so invest wisely. And we work with the Herz biomass boilers for that reason. They're long established, over 1,500 employees in more than 70 countries and 8 production sites. The boilers are fully automatic. The vertical heat exchanger to allow them to deal efficiently and effectively with the ash content that naturally comes with burning solid wood fuel. We do a full range in one boiler from 10 to 1 megawatt, 10 kilowatt to 1 megawatt. Best practice comes into play in all cases, but primarily in the biomass, it's very important to size the biomass boiler to satisfy on a commercial scale the base load demand. Or with a two-pronged approach, you need to look carefully at how you cover the full peak load demand of the building if you're doing a standalone biomass system. The difference in a biomass boiler or a gas system is the ignition and operation. Once the boiler is running, it'll produce heat and energy in the same format or same means as an oil or gas boiler. The initial starting process is the difference. They're much slower to ignite. The process of ignition, they bring in the fuel, they power the heat gun, they ignite. They need to run, or they want to run at that scale when they have ignited. Whereas with a gas boiler, if it fires now and it stops in 2 minutes, it has no real net effect. Certainly the efficiency of the system is lower, but it's more detrimental to a biomass system. So ideally, in best practice, the biomass boiler is sized to work on base load demand, whether it be 65 to 70% of the building's annual heat load, and in those means we are sure that when the boiler starts it works and works for a period of minimum 1 hour, 1.5 hours, so we're sure that the annual efficiency of the system is considerable. Need to integrate a suitably sized buffer tank, again depending on what you're looking to achieve, primarily to control the start-stop of the boiler. And there's various different ways that we use this buffer tank, whether it be to help the biomass boiler in a slide which we have further down. elaborate further on it, but we can use the size of the buffer to maximise the output of the biomass boiler as well as control the start stops. On most commercial applications, they'll have backup, so an oil or gas boiler would be recommended in most best practice to act as the backup or to assist if required on the peak load demand. One obstacle that we come across many times 5-6 years ago was the size. The physical plant, the size of a biomass boiler could be 2-3 times larger than a conventional oil or gas boiler, maybe more in some cases. Not to mention the fuel. On an oil system, yes, you're used to storing fuel, but the bulk density of wood chip can be 3-4 times greater than the space required for a conventional oil system. Pellet is 2 to 3 times smaller than wood chip. Just to give an outline of completed and ongoing projects, the sectors that we've worked in, how the systems have been integrated and what they are doing. So on this first example, we've installed 6 biomass energy cabins for retrofit applications for the Belfast Health and Social Care Trust. We're offsetting 202 tonne of carbons per year on a target to generate £67,000 per year on RHI, and the full design and independent heat meter report and RHI was processed through alternative heat. But again, on the like of this study, there was a feasibility study carried out before any contract was looked at or before any agreement was made as to whether it would work. For the Belfast Health and Social Care Trust, we looked at 14 sites, of which 6 were suitable, and the remainder were not deemed as best practice or certainly could be worked, but they weren't ideal solutions, I should say. But on this type of application, when the research is done beforehand, this information is clear. So the feasibility study lets the client get a better understanding of what the project is going to deliver, and then we can be held responsible at the end of it for making sure it does deliver that. The next example for Millbrook PRU School in Southampton, district heating scheme supporting 4 separate buildings. So on target to generate 27.5 grand per year in RHI and save 18 grand a year on fuel. This is a gas grid, so the fuel savings aren't as lucrative as the oil, which in turn leaves the payback up slightly, but still with 6-year payback, it's hard to knock. Again, a fully containerised plug and play unit. Space was an issue, they hadn't space on site, this was the solution. Loch Arbor Leisure Centre was a system that we done for the Highland Council. When we studied the heat load profile for the Loch Arbor Leisure Centre, it was similar to many other leisure centres we looked at. The peak load demand in the morning for 1.5 to 2 hours was 750 kilowatt, because the through flow of the early morning people in for showers, for use on hot water was at a peak, and it balanced out through the course of the day to average somewhere in around 350 to 400 kilowatt throughout the rest of the day. So what we did in this application was we integrated a 400 kilowatt biomass boiler with a 15,000 litre buffer tank, which helped the biomass boiler cover the peak load with the stored energy that she worked to produce through the night in the 15,000 litre buffer tank, and in turn generated a very good rate of return. We have a 400 kilowatt boiler offsetting what was a 780 kilowatt peak load, and using 1.5 to 2% of the heat generated for this premises through the course of the year is done through the backup oil boiler. And this is a site that was audited through the Carbon Trust, and it stands as a pillar to show that with the right design input, the systems can and do and will work very, very well. The idea is to get the qualified companies in at the early stage, show them what you're doing, give them a picture of what you're trying to achieve, and take the information back that they have on board to help vet and run feasibility studies before jumping in. Enniskillen Hotel was one of the first, if not the first, RHI approved application in Northern Ireland. Again, it was a containerised unit. It was an oil-fired central heating system that we offset, so they're generating 11,000 11.5 grand a year on fuel savings, on target to generate £17,000 per year in RHI, and they're in line for a fully fitted out containerised unit, a payback of circa 3 years. Again, the full design, layout, drawings and RHI was produced and run through by ourselves. Another example which is interesting, the agriculture sector, which we touched on, certainly in Northern Ireland poses an interesting sector for renewables and biomass. This particular site was a site that we started on maybe a year and a half ago, and initially we integrated 2 number 99 kilowatt biomass boilers to replace the direct fired gas brooders which were heating the poultry houses. There was a number of benefits to this scheme, in that the direct fired brooders in the houses absorb an element of oxygen which depletes the oxygen level within the house and creates a less comfortable space for the bird to grow. And through our research and development on this site, the biomass posed a benefit to fuel saving, also RHI advantage, but also a healthier crop, and the client is benefiting from a higher rate of return from his yield of birds. This site inadvertently has run on as 14 poultry houses on site. The first 2 were the test site, and we're set next month to complete the 14th house. So it proves that the system does works very well, and the rate of return is out there. Simple print factory setup in Duncrew. Again, 99 kilowatt, availing of the best tariff, 6.1 pence a kilowatt hour. Fully fitted out containerised units, offset in oil, believe it or not, in Duncrew, which again left a great rate of return, and in turn payback of 3 years. One major step which we've brushed over, and it has been talked of, is the upfront costs, and we're not blind to the fact that these systems are expensive. We're also not blind to the fact that there is an element of quality needed in it, so there needs to be a cost for the system if you're going to make sure it's going to run for 20 years. There is help certainly in Northern Ireland for that, as far as to avail of the RHI, you're not allowed to accept grant funding, or if you do, you must repay it to leave yourself eligible to claim the RHI. But for certain industries, setting aside the agriculture sector, which is not acceptable for loans under the Carbon Trust, quite a number of the slides that I've shown previously availed of an interest-free loan through the Carbon Trust, which helped for their initial outlay on capital costs. The interest-free loans pay back over 4 years, so self-sustaining. With the fuel savings and the RHI accrued, the loan was interest-free, self-sustaining, and in 3-4 years the client was on a win-win scenario. That's basically all I had to say, and thank you for listening.